So last time around, we were talking about summary measures or tendency measures for positions in statistical and probability distributions, and we talked about modes. I forgot one small detail in that video to say that you can determine the mode from by using the derivative of a point. I forgot to comment that the derivative has to go to zero and the point at the top has to have negative curvature, but that's a detail that doesn't usually matter that much in statistics in this case, because if there's more than one mode, there's more than one answer, and you don't usually want to use modes if there's more than one answer. At any rate, let's talk about the medians, which is the next thing. It's the value in the middle of a crescent or decreasing crescent or decreasing list of values of a distribution. So let's give you one example, or rather three examples. So in the discrete realm, if you forget about all of the other stuff written here, in the discrete realm, there are two possible cases of things that can happen. You can have an even number of things in your data set, and you can have an odd number of things in your data set. If you have an even number of things in your data set, you divide it by 2 and you take the n divided by 2 and divide by 2 plus 1, both of them. You sum them and divide them by 2. So for instance, there are 6, I divide by 2. The third and the fourth one are gonna be used to say what's my median here. So I will sum 3 and 4 and divide by 2. So 3 plus 4 is 7, 7 divided by 2 is 3.5. So the median of this data set 1, 2, 3, 4, 5, 6 is 3.5. Incidentally, this is the mean of a fair die because I am listing all possible results. And for quite a few distributions, the mean and the median are gonna coincide, but there is a difference between what happens in the mean and what happens in the median. In here, in a case in point is if I added another number here, a very huge number. So let's say there was a 100 here in this list. And let's say this list was a lot bigger actually in both sides. And this 100 is the only number that is a lot different than the others. The median is not very sensible to me adding 100 here because it's gonna go to 4 instead of 3.5 as we calculated. But if you do this with a mean, with an average, you're gonna have a huge dislocation of the average because of a big number. That is hypothetically here is 100. And you can see that for a low degrees of data, that's gonna affect all of my averages. And in fact, there are averages that are better at dealing with this type of thing, but the median can also deal with this type of thing fairly easy because it's not very sensible, at least not that sensible to an outlier, as means can be and usually are. Let's say now you have an odd number of things in your dataset for finding the median. So in this case, we have 5, we divide by to take the smaller integer and sum one, which is basically saying the same as take the value in the middle, and that's your median. This is in the discrete realm, and now we'll go to the continuous realm. So if your distribution is continuous, you're gonna have to integrate from minus infinity to a certain x in such a way that you have half in the end, half the probability distribution integrated. And you can do that from x to infinity too. It's the same thing. Basically, the picture is you have a curve here, and you're gonna integrate until you have two areas here that are equal, and each one of them is half. And if you do that, x is going to be the mean, this number here. So the median, pardon me. So let's give you one example of this, a fairly simple example. So let's say your statistical distribution is 0 for x smaller than 0 and bigger than 1, and is 1 for in the interval between 0 and 1. So the integration from minus infinity to x of this function has to be half by definition, which means the integration from 0 to x is going to be what matters, because outside of this interval, it is for sure going to be 0. So x at most can be 1, but it can't even be that, because the integration from 0 to x of 1 dx line is going to be half, and it's going to be x, so x is equal half, and half is the median of this distribution right here. This distribution is the uniform distribution between 0 and 1, so it's something like this. Y and x, this is 1, this is 0, this is 1. And the median is going to be this point halfway here, which is half. And that's how it will work in the continuous realm. For the continuous realm, much the same observation is valid. If you have outlier data, and it's not very frequent, it's not a very frequent outlier, it's not going to affect the integral too much. But for an average, or especially for arithmetic mean, this can be possible. So that's why a lot of times you're gonna see people using medians instead of means, because means are sensitive to outlier data, while median isn't that sensitive to outlier data. I think that's it for the median, and the next few times we talk about this, it's probably gonna be about the means. Bye for now.